Hi everybody, this is Dr. Dadu presenting the artificial neural network and our happy listening. Now, it is time to discuss packages that are written for specific purposes in NAV. An example of such package is the neuralnet. Well, but there is that problem of compatibility. I will assist by just telling you that to be able to run neuralnet, I'm using it on R version 4.2.0. It is compatible with that version. Now, neuralnet is written specifically for mimicking the transmission within the nervous system. The central nervous system, which is the brain in human beings, is a recipient of sensations. Now, if the messages are being transmitted, there is the weight that is attached to each sensation that helps in determining the severity. I mean, if somebody is being pricked with a pin, the severity is not, the pain attributable to that is not as much as being shot. As such, the weights are of paramount importance. Well, I decided to do a review on ANN before going to the codes and output, so that those that are not used to ANN or they have not seen it being modeled will have information pertaining to that before they go to the codes and the output. There's a reference material by Gunther and Frisk on neuralnet. The preliminaries, you would here see artificial neural network as an extension of generalized linear model. You recall that in my past videos, I've shown how to use the linear model, the generalized linear model. This can be seen as another extension on the generalized linear model. We also saw response surface. That's also important here. When you regress, there's still some information kept in there. That information, some of that information is what we are highlighting here. But the artificial neural network as an artificial attempt requires some things, e.g. training of the data or metadata, so that it is when the training is mimicked, is fully done, that it will work on extensions. Just know that the neural network is for biological gene interaction or natural organism transmission, either of ailment, disease, or what have you. But multi-layer perceptron, something of note here. That's talking about the weights. When you have just a node point, or the one we call layer point, a node point, the sensation from it is restricted. But when you have very many of them, say 2 or 3, for instance, what the brain receives, what the central nervous system receives, will be a convolution of the sensations. And to each of them, there are weights attached. O O is denoting output. It continues to iterate. At the first instance, this is the situation. When it does incrementation, when another sensation comes in, it does incrementation, and that will be the sensation. These are the weights. They are created in the multilayer perceptron. This is the simplest prototype. When there are just two sensation zones, these are latent or hidden nodes. Synapses takes place, and the directed lines are telling you how the flow goes. This is the output, the response. And attached to each of these synapses are the weights. You will see later by the time we come to the output. Supervised learning, like all artificial intelligence technique, you must do some training. ANN is not an exception in this case. The training is done, and the weight generation process is actually through resilience backpropagation. How is that different from the ordinary backpropagation? It's in the weight. Those who know will see that the weight generation here is a little bit different from the weight generation for ordinary back propagation. Actually, this part of it is the same, but this extension is a little bit different. That's the resilience part of it. Now, for our present presentation, neuralnet, data and training. In data sets in R, whenever you install R, there's data set that comes with it. It's in the base R. Data set comes in, one of the data in there, in fact, INFERT, in fact, shortened from infertility or infertilization. All right, that's the data we'll use for this presentation. And if you want information concerning it, you can just go to her, irrespective of whether you install neuralnet or not. Type help, open bracket, and type in fact, close your bracket and press the enter button. It will take you to where you see information on in fact. Same goes for any other data in the data set, that is. All right, the information on in fact will tell you that there are 248 observations. You will know the amount for control, the number of cases involved, all the covariates in there, what they stand for. It will be explained to you. Now, if as you run neuralnet, you also come out with some technical jargon. You would, in the material, neuralnet.pdf, nnet.pdf, you will see what these technical words stand for. Okay. O of X is the output. Visualization, it's extremely important. To most people, they don't want to be informed about the theory. They just want you to show them how it is done and what the output is like. If the output is in the pictorial representation, they desire it that much. There's a saying, seeing is believing. When they see it done, they believe in it. So visualization is extremely important. It tells the observer how the thing is done and how desirable it is. Aesthetics and things like that will be shown in the visualization. Here are the codes. Obviously, you start by invoking the neuralnet package. This is the model you will have seen in your help, in the help for in fact what these ones mean. Age parity induced spontaneous. The course continues. Head out, head of the infact when you want to know, when you want to see how the data is kept in our output, just like that. But plot nn, plot the neural network. It's very, very important. So these are the codes. All right, the output very, very lengthy. I've only chosen some part of it to highlight. This is when you want to know about the data. This is when you want to see the progression, the error being captured at that instance, the steps that are the progression. It continues like that. The weights generation until when you come to plot nn, which is the network itself. If you go back, you will see that the cardinality of the weights, 13. Okay, 13 weights are generated. And if you count them, you will see they are up to 13. And these are the covariates you are paying attention. Well, your choice of covariates may have been born out of the fact that you probably have done principal component analysis to know the covariates that are extremely important, or a factor analysis or whatever. So, and this is the summary, the error at that instant and the steps that it has overcome. This is to show how the covariates you are chosen are doing, how they fare. Age parity induced spontaneous, how they fare. And information on the output just tell you that the network is the most important, and the content of slide 13, that's the graph of how the covariates fared. The weights are as shown in slide 12. They are reaching over the directed lines, directed graph. So that's the farthest I intend to go on ANN, and watch out for my videos on the next in the series. Thank you. Like, share, and subscribe. Thank you. See you next time when I come with another package.